a good understanding of what a vector and a scalar quantity are, let's have a look at how to use them in an application. Position and time give you a ton of information when you use them together. I will assume you remember that we are talking about this in relationship to the red barn concept and that the motion is uniform. We are talking escalator or conveyor belt. In the Walk This Way lab, we had a uniform motion in the form of a student walking at the most uniform pace they could manage along a 50-meter course. The student walked down the hallway and then back with a slight rest in between. Because we timed when the student moved past a known distance in the course, we have enough information to create a line of best fit graph. Line of best fit is created when you collect experimental data that shows a grouping or a trend around a linear axis in a graph. It means we can extrapolate or interpolate, Wikipedia, data along that line. We create a line that is the trend of the best of our ability, but not necessarily hitting all the points. Something like this. It'll be more accurate if you use a computer to calculate it. Using the line of best fit, our graph in the Walk This Way lab should look something like this. It's kind of odd seeing that the path was on a flat and straight, represented in a graph that looks like a mountain. Graphs can be visually deceiving in that way. Let's deconstruct this graph so we can understand why it looks the way that it looks, and how to interpret uniform motion in a graphical representation. Slope might just be the key to this whole thing. I know, who knew you needed to listen to your math teacher for real? You all know slope. If you've ever ridden a bike up a hill or down a hill, you know slope. We can mathematically calculate all kinds of things. Slope is effectively the rise over the run of the line. A positive slope will have a line that climbs skyward. That doesn't mean the object is moving upward or climbing. It just means that the direction is north, up, right, or east. A negative slope means that it's moving downward, left, south, or west. The red barn principle applies. So what does the flat line mean? No, it's not death of something. Or maybe it is. The flat line is an indication of where the object stops. It isn't gaining any distance over time. I guess it's kind of like the death of motion. Now that you have a snapshot of what slope can do in a position time graph, let's look at the math of the slope. The slope is rise over run, which is distance or position over time. What else do we know that's measured in distance over time? Good thoughts! But we have one more piece of information to add. We have a position over time. That's a vector. When you add position, which means you add direction to the time and the distance traveled, we get velocity. What is the point, Jones? That was confusing. Here's the formula. Velocity is position over time. Let's try it in your lab.